This video is Module 3, working on Example 2, which reads as follows. Suppose we have the following hypotheses. The null hypothesis is that mu equals 4.2. In context, that means the average length of all wires from a production line is 4.2 inches. The alternative is that the mu is less than 4.2. Which reads in context, the average length of all wires from the production line is actually less than 4.2 inches. And it tells us in the problem that we have a p-value of 0.28. So again, before I start answering the questions, I want to get a sense of what is happening here, given the information that we have. So if we have a null hypothesis that mu is equal to 4.2, that means if we went out and we created our distribution of sample statistics, our null distribution, we know that it would be roughly mound-shaped. We also know that its center would be at mu equals 4.2 because that is the null hypothesis. About half of the sample statistics would be a little above 4.2, and about half the sample statistics would be a little below 4.2. This is telling us the expected sample statistic values that we should expect to get, the usual, normal, expected sort of sample statistics we would get if it is true that the average from the entire population is actually 4.2 inches. Next, I'll note alternative hypothesis is that mu is less than 4.2, and it gives us a p-value of 0.28. Remember, a p-value is calculated by assuming the null hypothesis is true and then finding the probability of getting a sample statistic like ours or more extreme. In this case, since the alternative hypothesis is less than, we are going to count samples that are like our sample statistic or less. That means since the p-value is 0.28, the proportion of sample statistics that are like our sample statistic or less is 0.28. 28% of the sample statistics are like ours or less. Thinking about that, that means I would probably put my sample statistic about here. My X bar, my observed sample statistic is about there. 28% of the sample statistics in the null distribution are like our sample statistic or less. P-value of 0.28 means 28%. That's a pretty big p-value. It's like almost 30% of the dots in the null distribution are like our sample statistic or less. So part A asks us to write out a sentence that gives the literal interpretation of the p-value in context. Again, what this means, and I always give you this hint here of what I'm looking for, you want to write a sentence that's using the p-value definition, but you're going to say everything in context. Again, remember the definition of p-value. It's saying if you assume the null hypothesis is true, then the probability of getting a sample statistic like ours or more extreme is the p-value. We just need to say all that in the context of this problem, meaning it needs to relate to the average length of the wires and the 4.2 inches and so forth. All right, so here's what I did. I rewrote that sentence exactly the same way. I just put all those phrases in context. So if we assume the null hypothesis is true is now, if we assume the average length of all wires from the production line is 4.2 inches, then the probability of getting a sample statistic like ours or more extreme is now written. Then the probability of getting a sample statistic like ours or less, remember it's less because that's how the alternative hypothesis was written. Mu is less than 4.2. And that probability is 0.28, 28% chance of that happening. 28% of the sample statistics look like ours or less. And then lastly, we want to take that actual p-value, 0.28, and make a conclusion in context. Basically, do we want to say that we think the null hypothesis is plausible, or do we have strong evidence against the null hypothesis? Do we have strong evidence in support of the alternative? Now, a p-value of 0.28, remember again, p-values at the end of the first page, we have a nice little number line to help us understand what kind of values relate to the type of conclusion you should make. P-values between 0 and 0.01, you should say you have very strong evidence in support of the alternative hypothesis. P-values from 0.01 up to 0.05, it's strong evidence in support of the alternative hypothesis. P-values bigger than 0.05, 5%, means that the null hypothesis is plausible. And that's what we have here. Our p-value is 0.28, 28%. That's definitely bigger than 0.05, 5%. So we're going to say the null hypothesis is plausible. But we're just going to say that in context. So I say, it's plausible that the average length of all wires from the production line is 4.2 inches.